We're reviewing decimals and rounding today. Again, this goes back for many years, but it's one thing that students often still have difficulty with is rounding. And as you go on in high school math, if you proceed to 10C and then either -1 or -2, you will have a diploma exam. In all of the exams along the way, you'll have what's called a numeric response type question where it's just a number answer, and you likely will have to round. If you round incorrectly, even if you understand the concept, you round incorrectly, you're not going to get the mark for it. So it's a really vital, important concept that you should know by now. If you don't, that's why we're practicing again. So things that you have to remember are place values, the names of them. So here's a number. You can see it's 1,234,563.891. To the left of the decimal point, you'll notice that it just ends with S. To the right, it's THS. Okay, ones digit, because those are numbers, that's a 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are just one digit numbers. Then that's tens, because that's 67, hundreds, thousands, 10,000, 100,000, millions, etc. To the right, there's no oneths digit. It goes right to tenths because one, in this case, this is 8/10. That means 8 over 10. If you divide that and get a decimal, you get 0.8. So it's 8 right after the decimal place. Hundredths there, so that would be 89 hundredths. 9 is the decimal, is the digit in the hundredths place value. And then thousandths, then 10,000ths, 100,000ths, etc. So similar to these, except with THS, and there's no once column. Okay, so rules for rounding. Locate the place value to which you're going to round. So this is what I do. Okay, so if you're asked to round to the nearest 10th digit, I circle that. Look at the digit immediately to the right of the circled number. These don't have an effect at all. So we want to look to the right. And then it's based on this number to the right. Not this one, just the first digit. If this is 5 or above, this 8 rounds up. If it's 4 or less, it stays the same. So now what happens when we actually round depends on the digit afterwards. So we want to look, as it says here, to the right. So we've chosen 8, we want to look to the right. And in these situations, this would be for 4 or less. This would be 5 or greater. For this, if I were to round this one, my digit to the right is 9, which makes this increase by 1. So it says if it's 5 or greater, add 1 to the circled digit and replace the remaining digits with zeros if the original is not a decimal. So this is a decimal, so this makes this go up to a 9, and then I would just leave it. So then all of these numbers would stay the same, right? If I had asked to round to, say, the nearest hundredth, so let me erase this part here. So say this, round to the nearest hundredth, then look to the right, it's a 1. Well, 1 is less than 5, it's 4 or less, so this would stay the same. And again, you wouldn't fill in with zeros. Now, if I asked you to round, let's say to the nearest 100, okay, then I would look to the right, it's a 6, that's 5 or greater, so this has to go up 1, so that would be a 6, and then I have to fill in with zeros, okay, till the decimal point. Because if it didn't, then it would be a much smaller number. Okay, so that's the rule that you got to remember. Biggest mistake students make is they start accumulate it. So they look to the very end and they say, okay, well, that leaves that a 9. This goes up to a 9. So that goes up to an 8. So this goes up to a 7. This goes up to a 6. In some cases, it might work, but not always. So you only care about the digit directly to the right. Okay, so round this to each of the place values listed. Nearest hundredth, so hundredth is the 8 there, so circle it and then look at the 3 afterwards. The 3 does not, it is 4 or less, so it does not move the 8 at all. It does not change it, so it's 295.08, and you don't put decimal places afterwards. Really, if you did, you're making the decimal more accurate. So you're saying that if we were measuring something, if we put zeros in there, that means we've measured to the nearest 10,000th digit, which really you didn't. Next one, the nearest whole number. Whole number means ones digit. So when we look at this, ones digit is the 5. Look afterwards, it's a 0. So that keeps that as a 5. And we do not put decimal 0000. Okay, just rounds to that value. Nearest 10. 10's digit is 10 is the 9. Now this is 5, so 5 makes the 9 go up 1. So when we add 1 to 9, we get 10. So it's like adding 1 or carrying that 1 from the 10 to the next place value. So that's going to be 300. Sometimes I think about I think of it in terms of money. So if you have this amount of money, obviously it wouldn't be to this many decimal places, but if you're asked to round to the nearest 10, you're basically saying, is this value closer to 290 or the next 10, which is 300? Well, if you take a look at it, it's slightly closer to, because of these decimal values, slightly closer to 300. Without it, it's halfway in between, but the rule is if it's 5 or greater, it goes up. Okay. Nearest hundreds digit is the 2. Look to the right, it's a 9. That makes that go up to 300. Okay, so rounding to the nearest 10 and the nearest 100 give you the same number in this case. Nearest thousandth with a TH. So remember that's 10th, 100th, 1000th, and a 5 afterwards. 5 makes this go up to a 4. So 295.084, and you don't fill in with zeros. And then nearest 10th is this 0 here. This 8 makes that go up to a 1. So 295.1. All right, comparing numbers. You must compare the same place value digits of any 2 or more numbers, starting from the left. If the digits are the same, you continue to compare the next digit to the right until you find a place value that is different in both numbers. The number that has the largest digit in that place value is the largest. So you're actually comparing from the left, the biggest place value. Because if the biggest place value is different, then it's easy to tell. So circle the largest numbers. So here we have 3 decimal, 3 decimal, so those are the same. Then 10th digit is different from this 10th digit, and this is bigger, so that's the larger. Okay, even though the 18 was the same in both, that was bigger. Okay, 92 was the same in both. Decimal 0 was the same. Decimal 03. This has a value in the thousandth column. This doesn't. So really that's considered to be like a 0. So 8 is bigger. Here 0.943, 0.3934, same digits, just not in the same place values. So the 9s are good, but this is 4 and this is 3. So this is bigger. Okay, so a numeric response question, and you'll get some on your test this semester, certainly in 10C, and then 20-1-2, 30-1-2. So there are 4 boxes to fill in with the digits 0 through 9. Okay, or a decimal point in a numeric response question. So you're never going to have a fraction, you're never going to have variables, you're never going to put units in it, you will never have a negative sign. Okay, so just digits in the boxes or a decimal point. So it has to be, the answer has to be 4 digits or less. Okay, a decimal point takes up one of the boxes if there is one. If it's a 1-digit answer, you don't fill in the empty boxes. And you always start with the leftmost box. Okay, so if there's 4 boxes and the answer is 2, it goes in the first box. Numeric response answers will never be negative and will never have variables. So that's a good way to know if you get a negative answer in a numeric response, you know to go and check your work because something went wrong. To the nearest 10th. Okay, we're going to answer these questions and then fill them in a numeric response set of boxes. When you actually write a diploma exam, what they will have, and we do this on some cumulative exams as well to get practice, but they have a bubble sheet underneath. So underneath you would also bubble in what these numbers are, and that's really what gets read by a machine, are the bubbles. But to save space, we're just doing the boxes here. So rounding this to the nearest tens digit, I'm going to circle the tens digit, which is the 3, and then I look at the digit to the right, which is an 8. That's bigger than, is 5 or bigger, so that makes the 3 go up to a 4. So there's the first 4, next 4, and fill in with a 0, and that's it. You do not put a decimal and anything else. And you start in the leftmost box. Okay, so 440 is the answer to that one. Next one to the nearest whole number. That's your ones digit. Look to the right, it's a 4, so that's 4 or less, so that means this stays as a 6, and that's it. Okay, so you do not put 6.00. That's saying that you've really measured something and rounded to the nearest hundredth. You haven't, you're rounding to the nearest whole number. So 6 goes in the leftmost box. Evaluate this, that's going to be 16 plus 5 is 21. So that goes in the first 2 boxes. Notice how if you had evaluated this incorrectly and put negative 16 plus 5 is negative 11, you cannot fill in a box with a negative or a variable or an exponent or anything. So you would know, got to go back and try it again, okay, till you get something that's at least positive. All right, and then just adding and subtracting decimals, a review, again without a calculator. So adding and subtracting, you want to align the decimal places vertically, and that thus means you're aligning the place values. Add and subtract the columns starting from the right and working to the left. For adding, you may have to add a 1 to the column to the left if the sum of the digits is 10 or more. And then for subtracting, you might have to borrow. So let's look at the first example. You've been doing this for a long time. So write out the first number. Then notice this is 21.79. Decimals have to line up. So there's 21. So there's a tens digit, ones digit, 7, 9. And we're adding. So you start at the right. 1 plus, if there's nothing underneath, it's a 0. So that's 1. 9 plus 3 is 12. So you want to write your 12 with the 1 in the column to the left. Then 1 plus 0 plus 7 is 8. Decimals follow down. 4 plus 1 is 5. 2 plus 0 is 2. Okay, next one, order. So in the adding, you could have put the 21.79 first on top. Subtracting, you can't. So 9.27 has to go first. Then 3.632 has to go next. You're subtracting. If there's nothing above to subtract from, really it means there's a 0 there. And so that means you have to borrow 10. So that means this becomes a 6 and this becomes a 10. So you've really taken that and shown it 10 in the thousandths digit. So then 10 minus 2 is 8, 6 minus 3 is 3. Again, we can't take 6 from 2, so we have to borrow. Okay, and then 12 minus 6 is 6. Decimal place stays the same. 8 minus 3 is 5. Multiplying and dividing, you align the last digits, not the decimal places. So I'll do this and describe it as we go. So 7.36, and then I'm going to put the 8 right underneath the last digit. Okay, decimal 1. So basically the digits line up, not the decimals. So, and you start from the right. So we're multiplying, and you want to start with the rightmost column and multiply together. So just like adding and subtracting, you start from the rightmost. So that's 48. So your 48 has to look sort of across like that. So this 4 really means you've got 4 in the next bigger place value. So now when you multiply 8 times 3, but you add 4. So 8 times 3 is 24, plus 4 is 28, and again, there's your 28. 8 times 7 is 56, plus 2 is 58. Then we have to put a 0 underneath that column because now we're multiplying by the next digit, the next place value. So 1 times 6 is 6, 1 times 3 is 3, 1 times 7 is 7. And this is where we have to add these columns. And then we count up the place values. So here I've got 1, 2, 3 decimal digits. So I'm going to have 1, 2, 3 decimal digits. And the decimal goes there. Think about, does it make sense? So 7.36 is about 7. 1.8 is about 2. 7 times 2 is 14. This is 13 point something. So it makes sense that you've got the decimal in the right place. Next one, 21.4. And then line up the 5, 3, 0 point. Okay. And so start at the right. 5 times 4 is 20. There's your 20. 5 times 1 plus is 5 plus 2 is 7. 5 times 2 is 10. Then 0 underneath. 3 times 4 is 12. Carry the 1. 3 times 1 is 3 plus 1 is 4. 3 times 2 is 6. And you don't need to do the zeros. It would all be zeros. Add. And count up your decimal digits. 1, 2, 3. 1, 2, 3. Okay, 7.49. And let's see, 21 multiplied by 0.35. So 21 times, let's say 20 times 0.4 is 8-ish, and this is close, 7.49. Okay, so it makes sense. That's it.